Graphvs is specialized in computer-based decision support systems to solve distribution logistic routing problems of its customers. This video presents one of Graphvs' systems, SISROT LIX. The processes of garbage collection can be classified in urban garbage collection, street sweeping, commercial or industrial garbage collection, garbage collection in health units, selective garbage collection. SISROT LIX is a software used to organize routes of urban garbage collection, commercial or industrial garbage collection, and street sweeping. It is specialized in generating routes using state-of-the-art procedures considering load-based clustering of street segments that correspond to one trip of a regular garbage collection truck weighing around 9, 12, or 15 tons, for example. We've selected a part from the metropolitan area of Fortaleza City in the state of Ceará, Brazil. The system permits an organized reconstruction of garbage collection in regionals, using the idea of partitioning. These partitions are made in 3 layers: regionals, trash generator zones that we call ZGLs, sectors, and circuits. At first instance, we group in regionals. A regional can be understood as a grouping of ZGLs. Let's associate this region of the map to just one regional. Here we have a total of about 317,000 kilos of trash for the entire regional. This load was previously estimated at an average of 850 grams of trash per meter in this region, but it can be adjusted based on the load history of the collection in the area. After we divided the regional in trash generator zones. A ZGL is taken as a collection area of a group of vehicles that works in the same day. Let's divide this regional into 2 ZGLs. This division is up to the company, public organization, or mayorship, which establishes it accordingly to the type of the area. For example, areas which must be collected every day, areas with more or less volume of trash, and etc. Imagine that Zone 1 is covered on Mondays, Wednesdays, and Fridays, and the other one on Tuesdays, Thursdays, and Saturdays, for example. See the load for Regional 1 divided for the 2 zones. Now we're going to divide zone into sectors. A sector can be understood as a collection area of one only truck in the same day. Let's suppose the fleet we have available be composed by trucks that carry up to 9,000 kilos of load per journey. Working primarily on ZGL1, that has about 157,000 kilos of trash, we note that it will be necessary 18 journeys to collect all this trash. Let's admit each vehicle does up to 4 journeys per day. Here we already can think about restrict the circuits, minimizing the numbers of the sectors. Thinking about it, we can generate 5 sectors, and the best configuration for that option would be 4 sectors of 4 journeys and 1 sector of 2 journeys. Knowing this, we can use an algorithm that groups the sectors considering the load way. Following this reasoning, we're going to generate sectors which need a maximum of 4 journeys each. In other words, 4 plus 9,000 kilos equals 36,000 kilos. We can still edit areas manually, taking street segments from one group to another. After that, the load planned for the brown sector was broken. We will keep trying to balance the loads. But ultimately, we could have a scenario inside the initial planning. All sectors with no more than 36,000 kilos of trash. And finally, we will divide each sector into circuits. A circuit can be understood as a collection area of one journey did by one truck. In other words, each circuit must be composed by only 9,000 kilos of load, the full charge of one truck for one journey. Now we're going to generate circuits for each one of the 5 sectors. Now we're going to make the same process for ZGL2. Here we have the circuits generated previously for ZGL1. This is the result for ZGL2. Here we can view all circuits for Regional 1, always respecting the limit of 9,000 kilos of load. Now we're going to choose any one sector, which corresponds to one direct journey of a truck, and then check its circuits to generate a route. The green point indicates a garage, from where the truck leaves, and the blue point a landfill, the end of the journey. We can position these points everywhere. After we localize the landfill and the garage, and know each truck's coverage area, we're going to calculate a route. The routes were made considering the garage are not a disposal place as the origin of the collection, and a disposal place which can be a transfer station or a landfill as the final destiny. Routes can be calculated considering different strategies. On strategy 1, routes are created respecting the circuits built by the user. Strategy 2 doesn't consider the circuits built. It considers the whole sector as one, make a giant Chinese postman tour, and the truck goes getting loaded following the giant tour. When its capacity is reached, it goes to the disposal site, return to that point, and follow the giant tour until all garbage is collected in the sector. Strategy 3 considers the same giant tour as previous, but is processed a cluster in the meanwhile the truck is following the tour. Finally, it reprocesses the routes between a garage and disposal site for each cluster of street segments. Let's use strategy 1 once we have already made the circuits of the sector 4. The methods generate routes in an optimized sequence considering the starting and arrival points using the state-of-the-art heuristics to the rural postman problem. Let's expose the routes following the sequence suggested by the system. The algorithms trace routes also minimizing U-turns for making the driver's work more comfortable and easy, reducing his effort and driving. These were the tors solved. Let's show another way to plan routes. We can consider this area of the map as one only big sector, so we can generate the circuits and check the grouping that has been done. These are the circuits solved. From now on, we can associate circuits to sectors, then sectors to ZGLs, and so on, making the reverse process. The same process developed before can be adjusted to organize the sweeping process. When we made routes for the urban garbage collection, we defined a proportion between trash load and covered distance. Here, it's sufficient that we consider the work as the distance in meters, so we can plan on the perimeter of the covered area. Let's divide the map into one regional composed by two ZGLs. For dividing ZGL1 into sectors, we're going to suppose that each sector group a perimeter that will be swept during a week or 5 days. Covering an average of 2.5 thousand meters per day means each sector must contain a maximum of 12.5 thousand meters. This is the division into sectors that will be done by human street sweepers, which can also be edited manually. Visit graphvs.com.br and know other DSS solutions by Graphvs.